Hello everyone, good day. In this video, we are going to discuss the different types of Kubernetes services. If you like this video, please subscribe to VSPARKZ channel and click the bell icon for the latest updates. This is the agenda of this video. We are going to discuss on these topics in this video. Just a recap on what Kubernetes services are. The basic problem with the pod networking is that the pods are ephemeral and it can be destroyed and created at any time. So it is not viable to depend on the pod IP addresses as it may also get changed from time to time. To solve this problem, we are using Kubernetes services. Kubernetes services provides an abstraction layer on top of one or more pods. Obviously, these pods runs our applications within it. Kubernetes services actually connect a set of pods to an abstracted IP addresses and a service name. Once the clients hit the services, we will be able to reach the pods which are running our applications. This method solves the earlier said problem wherein even when the pods are recreated, the static IP of the service remains the same. Now we will discuss the different types of Kubernetes services. Types of services. There are basically 4 types of services available in Kubernetes. They are ClusterIP Service, NodePort Service, LoadBalancer Service, ExternalName Service. We will discuss about these services one by one. ClusterIP Service. ClusterIP Service is the default service type and it is the most common type of Kubernetes service. When a ClusterIP service is created, Kubernetes will assign an internal static IP address to that service. This static IP address is a virtual IP address and it is accessible only within the Kubernetes cluster. This cluster IP address is not accessible outside of a Kubernetes cluster. But why we need to create a Kubernetes cluster IP service? We will see it in the next slide. Usually, cluster IP services are created to enable inter-service communication within the cluster. For example, if we closely look at this picture, we are running front-end web server component and the back-end DB component in the cluster in the form of pods. In order for our external clients to reach the web server pods should be exposed to the external network. In order to implement this, we can use Kubernetes services like NodePort Services, LoadBalancer Services, or Ingress Services if needed. But how do the front-end web server pods communicate with the back-end database pods? That is with the help of ClusterIP services. In order to reach the back-end pods, the front-end pods will hit this ClusterIP service. This back-end ClusterIP service will route the request to the back-end database pods. But why this type of routing? It is because the back-end database pods may have sensitive informations. We should not expose the back-end database pods to the external world. But it should be exposed within the cluster in order for the web server to reach database pods. In other words, this service type is used for internal networking between the workloads that are running within the cluster. NodePort Services. NodePort Service is an extension of ClusterIP Service where we are going to expose our applications to the external world. When we say external, it means outside of the Kubernetes cluster. When we create a NodePort service, under the hood, it just creates a service port mapped to the target port, which in turn gets mapped to the pod port number. So when we hit this service port number, we will reach our application. Up to this level, the traffic flow is exactly equal to the ClusterIP service. Additionally, on top of this, the NodePort service maps the worker node's port number with the service port number. Now this NodePort service is exposed to the external world using the worker node's port number. These node ports must be in the range of 30,000 to 32,767. In this example, the node port number is 30,000, service port number is 8081, and then the target port number is 80. Whenever our external clients hits node IP colon node port number on any of the node, simply the traffic will be redirected to the service port. This traffic is then redirected to the target port on the pod's port number. This is how the external traffic will reach our application. The node IPs will be different for different worker nodes, whereas the node ports are same for all the nodes with respect to NodePort services. Just as a side note, our clients can hit any of the worker nodes IP to reach the application. Load Balancer Services. Load Balancer Service is another type of Kubernetes service with which we can expose our applications to the external clients. But this service is possible only when you are running the Kubernetes cluster in a supported cloud platform. AWS, Google Cloud, Microsoft Azure are some of the supported cloud platform vendors that supports this type of Kubernetes service. Let us discuss how this service type works. For this example, we will take AWS for understanding the Kubernetes load balancer services. Assume that we are running our Kubernetes cluster in AWS using EKS, that is Elastic Kubernetes Services. EKS is the managed Kubernetes platform offered by AWS for running our Kubernetes workloads. When we create a Kubernetes load balancer service in this cluster, it will automatically detect the cloud platform with the help of Cloud Controller Manager and creates a platform-specific load balancer. In this case, the platform-specific load balancer is Elastic Load Balancer or ELB. This ELB is accessible from the external clients using the external IP addresses or DNS name. So, when an external client hits this ELB, the traffic will be forwarded to the worker node's port number. From there, it will be routed to the concerned pods where our application is running. Same will happen if another client hits the same ELB, but this time it will get redirected to another node. By this way, this ELB distributes the traffic evenly across our application pods. This load distribution mechanism is fully dependent on the Elastic Load Balancer. ExternalName Services. ExternalName Services offers the flexibility of accessing the external services or applications from or within the pods. This type of service is useful when we have our application component outside of the Kubernetes cluster. For example, a database component which is running outside of the cluster and we want to access it from the Kubernetes cluster. An external name service maps the service name to a fully qualified DNS name instead of selector. This type of DNS record is called a CNAME record, where a name gets pointed out to another name. The DNS resolution for these names will be done at the cluster's DNS level. Let us consider an example of creating an external name service having a name prod-db. When we hit this service name from the application pod, the Kubernetes cluster DNS component, so-called core DNS, will look up that the external name service prod-db has external name set and its DNS name is mydatabase.vsparks.com. Now the application pods will reach to the external database. Few advantages of using this external name service are: no need to hardcode any IP addresses of your external component. Simply, we can create a DNS CNAME record and use that DNS name in the external name service. It also helps to separate our external components from that of the Kubernetes cluster. Service manifests. Let us now compare the YAML manifest for different types of Kubernetes services. Here are the YAML manifest for ClusterIP Service, NodePort Service, LoadBalancer Service and ExternalName Service. Key differences between these services lies under the spec field of the service manifest. Please see the spec field of the ClusterIP service. Under this field, we can see the type is specified as ClusterIP. This type is an optional field for ClusterIP services. If we did not mention any service type, Kubernetes by default will try to create a ClusterIP service only. We can also see in the ports section that we have specified the service port, protocol and the target port. Similarly, if we look at the NodePort service, the type will be NodePort. Also, we can see under the ports section an additional field called NodePort is added. This is used to expose the service to the external world using worker node's port number. This field is also an optional field. Kubernetes will automatically assign random port number within the range of 30,000 to 32,767 if we did not explicitly specify a node port number. If we look at the load balancer service manifest, it is exactly equal to the ClusterIP service including the ports, but the only difference is its type. Here the type should be load balancer. Finally, it is the external service name. Here the type is external name. For external name service, there is a special field called external name, where we need to specify the DNS name of our external component. All the other fields like selector, ports are not required for this type of service. Well, that's it for this lecture. This is the summary that we have discussed so far in this video. Thank you from VSPARKZ and thank you for watching this video.